Welcome. Today we're going to continue talking about analyzing categorical data. The learning targets for this video are going to be I can construct and interpret two-way tables for categorical data, and I can describe the relationship between two categorical variables using marginal and conditional distributions. So yesterday we talked about the basics of if I just have some categorical data, how can I describe it? Today is all about what if I want to make comparisons between categorical variables? Then how do I do that? Well, first of all, to represent multiple categorical variables, we're going to be talking about two-way tables. Okay, two-way tables are the best way to show two categorical variables, organizing counts according to the row variable or column variable. When a data set involves two categorical variables, we begin by examining the counts or percents, which are often more useful, especially when comparing groups of different sizes, in various categories for one of the variables. So yeah, again, when you're comparing them, if you have 100 people talking about one variable and only 50 about another, well, those counts are different. So counts aren't that useful. It's percentages that end up being useful when we're talking about categorical variables. So to talk about if you're given a two-way table and you're being asked to describe one variable at a time, you're going to want to find the marginal distribution. Okay? The marginal distribution of the categorical variables in a two-way table of counts is a distribution of values of the variable among the individuals described by, excuse me, by the variable. Okay, so I know this is really, really wordy. So let's dive right into what this looks like. Okay, so here is some data. Okay, a sample of 200 children from the United Kingdom, aged 9 to 17, was selected from a census at school website. The gender of each student was recorded, along with which superpower they were, excuse me, they would like to have, either invisibility, super strength, telepathy, ability to fly, ability to freeze time. All right, so there's all of the data that we have. Now, so you're probably wondering, first of all, what is this marginal distribution stuff? Okay. So marginal distribution, okay, that's going to let me look at one variable at a time, okay? So for example, let's say I'm just interested in general about these superpowers, okay? So I just want to know about the superpowers, okay? What does that distribution look like? Well, that is what the marginal distribution is, okay? So on the next page, if you notice, it asks us, use the data in the two-way table to calculate the marginal distribution in percents of superpower preferences. So here now, we're ignoring gender. All we're doing is we're looking at the superpowers, okay? So the marginal distribution of superpowers, the first thing I would do is list out, since that's the marginal distribution we're looking at of superhero preferences, list each of those preferences, okay? Now I know obviously I have the table made for you, but I mean in your homework tonight, the marginal distribution of superpowers, well, list the superpowers, okay? Now how do I find the marginal distribution from there? Well, again, let's flip back. So the marginal distribution is going to be there are 30 people that want invisibility. Okay, 30 of the 200 kids wanted invisibility. So 30 out of 200, 30 divided by 200, that is going to give me 15%. Okay? And then I would do the same thing over and over and over again. So for super strength, there were 3 female, 17 male, so a total of 20 people. So for super strength, there were 20 kids that wanted super strength. Out of 200, that would be 10%. For telepathy, there's a total of 44 total. 44 out of the 200 is 22%. Okay? So that's how you find these marginal distributions. label out the categories, find out the total of people that wanted invisibility, total people that wanted super strength, so on and so forth, and then divide by however many people that were part of that sample to get the percent of people for each of those. Okay? So that's the power of marginal distributions, right? It lets you look at one of the variables at a time. This time, the variable of what superpower they would want. And then, of course, we can turn this into a bar graph. All right, so over here, please fill in that bar graph based on the marginal distribution that we just did. So again, this bar graph is marginal distribution of superpower preference. That would make a good label for this, or a good title. And again, I labeled the preferences, I labeled the percents, so this would obviously be a relative frequency bar graph. And again, when we're talking about marginal distributions, it would always be a relative frequency bar graph. And once again, the important piece to this is describing what we see, okay? What do we see in this graph? Well, flying and freezing time seem equally popular, followed by telepathy, invisibility, and super strength. Okay, so again, just labeling what I see. I noticed the top two were pretty equal, and then I just kind of listed it from there. Well, then it was telepathy, visibility, and the smallest was super strength. Okay, but again, notice I used a full sentence, and I used a complete thought for that. Okay. So that's marginal distribution, okay? Now, notice marginal distribution tells us nothing about the relationship between the two variables, okay? So when it comes to making comparisons or talking about the two variables together, it's not actually that useful, okay? This tells us nothing about the gender breakdown for each of these things. So we need to take this a step further. There's another type of distribution. It's called the conditional distribution. Okay, and it describes the values of a variable among individuals who have specific value of another variable. Okay, so this is where it starts getting a little bit confusing. So please, please, please pay very close attention. And if you're confused about anything, jot down notes or highlight stuff in this packet that you're confused about so you can ask me about it in class. Because I know this part is where kids start getting a little bit lost. Okay, so to compare male versus female answers, okay, maybe I'm interested in how does being female change your responses from being male? Or is there a difference in those distributions, okay? So if I want to know if there's a difference in female responses versus male responses, I'm going to find the conditional distribution of responses for the males and females, okay? Now, what does this mean? Well, what this means is I'm isolating male and female. So my focus are how did males answer and how did females answer, okay? So first, obviously in this table, notice I'm talking about females first. So I'm going to go back and I'm going to look at this table, okay? So conditional distribution. So I'm going to focus only on the female responses right now, okay? So conditional distributions focus only on a particular trait. So here I wanted the difference between male and female. So I am isolating female answers from male responses, okay? And this time I want to know what percent of females wanted invisibility. So to calculate that, this time for invisibility, 17 out of 115 women wanted, or not women, sorry, these were kids, females wanted invisibility. While only 13 out of 85 of the males wanted invisibility. So this time we're looking at that comparison, okay? So the conditional distribution is breaking it down into, if we're comparing gender, well, isolate those separately in your table, and now you're finding the percent only within that particular category. 17 out of 115 females, 13 out of 85 males. And when you do that, you get those, okay? You can do the same thing for super strength, okay? Let's say I wanted super strength. So this time, for super strength, 3 out of 115 females wanted super strength. 17 out of 85 of the males wanted super strength. Oops, sorry, I forgot those would disappear again. So this time we're talking about 3% versus 20%. Okay? So that's how you break down conditional distributions, okay? And I recommend actually going to the table when possible. You can't obviously write in your book. But if you're breaking in down responses for males versus females, I would actually draw boxes around those parts of the table so you can see that you're isolating your answers for males separately than females. So I'm going to help you fill in the rest so I don't take all of your time just doing computations that you saw me do already. But I do encourage you, once you're done with the video, go back and make sure you can get those values. Make sure you can figure out where those values are coming from. And if you can't, great opportunity to ask me in class tomorrow if you're not able to find those values. Okay? So now we need to figure out, how do we display this data? Numbers are great, but displaying the data is usually the key, because that's how you can look at the differences. So you can still use bar graphs. However, we have to kind of make different bar graphs here, okay? Adapted bar graphs. So the first one is a side-by-side bar graph, okay? So notice for a side-by-side bar graph, I identify males versus females because that's really what I was interested in, okay? How are males and females responding differently? And then notice I group those together. Male, female, male, female, male, female, male, female, male, female for both. Okay? To show how they're comparing to each other side by side. Okay? Now, the other way that you could do it is what's called a segmented bar graph. Okay? So, a segmented bar graph, well, that looks a little bit different, okay? So for a segmented bar graph, comparing males and females, I'm going to choose one of the superpowers. So here, let's start with invisibility. All right? And I'm going to check the difference between males and females for invisibility. So I'm going to go back to my table, and I'm going to see both had 15%. Okay? So I'm going to come up 15% for both of them. Now let's say we're going to stack on super strength. So for super strength, let's see what they had. Super strength, females only had 3, males had 20%. All right, so let's go up. So 15 plus 20, I should come up to around 35% now for males. And the females only had 3%, so I'm only going to come up to the 18 now. So a segmented bar graph, you're stacking vertically all the different things, okay? So you can kind of see how they compare side by side. Let's look at telepathy. So 34% versus 6%. Okay, so right now I'm up to 18%, so I need to add 34%. So now for telepathy, that's going to take me up to just over 50. Males only had 6%. So that's only going to bring me up to the 41 mark. So notice that's the easiest way if you're actually trying to make a segmented bar graph to stack them like that. I'm just adding up. So for example here, I know this was 15. This was 20. So now I know I should be up to the 35. Then I did 6. So now I know I should be up to the 41. That's a nice way to figure out how high you're going, okay? Because you're keeping track each time what you're at. So here this is 15, 3. So that's why I was saying I was up at 18. 34, that's why I knew I was up at 52. Flying, 31 versus 21. So I was at 52, and now I'm going up 31 more. So now I should be at around 83%. And for males, I was at 41, going up 21 more. Going to be at about 62 now. Right, and then, oh, I'm sorry, I forgot to label it over here. Then, sorry, I have to repeat a color. Actually, wait, I can change the color here. So now, our last one is going to be freeze time. Your last one will always bring you up to 100%, okay? That's how you know you've done it right, is when you're making segmented bar graph, when they stack on top, they should add up to 100 that way, okay? So again, two different ways you can represent graphically the information that you just found in your conditional distribution. So write a brief description of what the conditional distributions tell you about the relationship between gender and superpower preference. So again, full sentences, complete thoughts. That's always what I'm going to be looking for. So based on the sample data, females were much more likely to choose telepathy than males, and slightly more likely to choose flying, while males were much more likely to choose super strength or freezing time than females. They're about equally likely to choose invisibility. So notice what I was looking for. The things that stuck out to me are when females chose one a lot more than males, when males chose one a lot more than females, or when they were about equal, okay? So I noted those key features. You don't have to say everything. Notice things that stick out to you, okay? Big differences or commonalities, okay? Again, I do encourage you, make sure you write all of that down because, again, you're practicing good skills at how to give good descriptions, all right? All right, now, four-step process. This is something right now, it's just kind of an introduction to what the four-step process looks like. Come second semester is when this becomes utterly, utterly important, okay? So, the four-step process, state, plan, do, conclude, okay? So state, you want to state what question you're trying to answer. The plan is you writing out, what are you going to do to answer this question? What statistical techniques does the problem call for? Do, make graphs and carry out the needed calculations. Conclude, give your practical conclusion in the setting of the real world problem. So again, this is going to become very, very important later on. Right now, we're just kind of introducing you to this idea of the four-step process so you get used to showing your thought process, okay? Because again, that alone can earn you points on the AP test. If you can show your thought process, that's going to very, very much help you. So, Based on the survey, what can we conclude boys and girls differ in their preferences of superpower? Give appropriate evidence to support your answer. So, when it came to our big question on is there a difference? Okay, this is what the four-step process would look like in describing that difference. Okay, so state. So the question is, what is the relationship between gender? And the answer to the question, what superpower would you prefer? We're looking for a relationship there. The plan, we suspect that gender might influence a child's opinion. So we're going to compare the conditional distributions for responses for males alone and for females alone. The do step. We have provided a table and two bar graphs comparing the opinions of males and females. We will use percentages that account since the number of females and males are different. Okay, so again, note here, now I didn't show the bar graph again because that was previously, but in this step, this is where you show calculations, show your graphs, stuff like that. Again, we already did that, so I'm not going to go back and redraw any of the graphs you've already done. The conclude. And again, this was kind of that paragraph we already wrote. Based on the sample data, females were much more likely to choose telepathy than males, slightly more likely to choose flying. So all of this, basically that's just verbatim what we already wrote. But in conclusion, yes, this does support that there's a difference of preferred superpower based on gender. We don't say absolutely there is. We're saying this supports that there could be a difference, okay? And that's what we're going to get to later on in the course, the second semester, is how do you gain enough support? What is enough to conclude that there is a difference, okay? That's coming later. This, again, is merely the foundation of that. So you have an idea when we come back to this second semester what we're talking about. All right, so again, if you had any questions, I know this is a lot to take in today. So if you have any questions, please make sure note those questions in the packet so you can ask me during class when you see me tomorrow.